Hello friends, this is Durga again from ITversity. As part of MapReduce application development using Hadoop based APIs, in this video we will try to see how we can actually implement the joins or lookups using distributed cache. So these are the high level steps which are required to implement. First we need to understand the data and understand the problem statement, and then we need to create all the necessary mappers, and then we have to take care of rest of the stuff. So to demonstrate all these things, probably it will take 3 to 4 videos, and we will see the entire life cycle of how we can leverage distributed cache to perform these lookups and joins. So first let us understand the data. My data set is in this location on my PC. It's under the research big data NYSC, and as you have been seeing, we are using New York Stock Exchange data for almost all the MapReduce applications, and we typically work on the raw underscore data directory. If you go to the raw underscore data directory, there is a directory for each and every year, and for each and every day there is a file in that. So for example, you can do 2009 / you can see for each day there is a CSV file, and let's copy one of the file name and cat on that, and you can see that first you have stock ticker, second is date, and third one is open price, fourth one is high price, fifth one is low price, sixth one is closing price, and last one is volume. So we can run analytics like top 3 stocks, average volume by month, total volume by month or average volume by month. Those kind of aggregations we can run on this data set. But if you are familiar with stock industry, all stocks are categorized into sectors. So a group of stocks will fall into one category of sector, and at times it might be relevant to run analytics on sector. And also another use case is, if you look at this one have only the stock ticker, and we don't know what this means unless you go through the metadata of these stocks and understand to which company the stock belongs to, and also to get the sector industry information for the stock. This data set is not enough. For that purpose, we need to do joins or lookups where we can join this data set with some other data set which have that information of stock name, sector, industry, etc. For that, in my PC, I have this directory called company list, which have this company list underscore no header.csv. If you open that file, you can see that the first field is stock ticker, second field is stock name, and then this is sector, and this is industry, and there are few more fields which are relevant to the stock, which are like macro indicators about which includes market cap, IPO year, and all those things. So we can use this data set to join with our raw data, which have end of day information of each and every stock, and then we can get the stock name for a given stock ticker. We can actually do the aggregations by running totals or sums on certain things, and get more insights at sector or industry level. Okay, so this is about data set. We will be using raw data and the company list. If you want this company list file, again it is under my GitHub account. You can go to my GitHub account, and there are repositories like code and data. All the data will be under data repository, and it has a directory called NYSC, and you can get all the raw data as part of this tar gzip file, and you can get the company list from this file. You can open from here also, and it has the stock ticker, and the delimiter is pipe. So you need to keep this in mind, because we need to develop parsers for these things. So that's about data, and let's define problem statement. Our problem statement is to join our raw data with this company list and get the company name for each and every stock ticker and the industry and sector, and load that data into a new HDFS directory. So overall we have WC minus L raw data NYSE *.csv. We have 3,471,692 records. So for all these records, we need to get the stock name, industry, and sector, and we can use that join. So the outcome and the output also will have 3,471,692. But for each and every stock ticker in the data set, will have its corresponding stock name, sector, and industry. Okay, and we will not be doing any aggregations or anything as part of this program. That being said, so we understood the data, we understood the problem statement. And we will see how parsers needs to be created as part of this video, and as part of the subsequent videos we will see the rest of the steps. So for that we are going to the same package. Again, this code is already available in GitHub, which I have explained several times in the past, so I'm not going into details about my GitHub account. Let me just give you overview where this code is, so that you don't have any confusion. So the code will be under my account. There is a directory called code, and for Hadoop there is a Hadoop directory, and under that you can get all the code that is being demonstrated as part of NYSE directory. Okay, it's a Maven project, so you can download this directory and you can actually import into Maven. So that being said, now let's start creating the parsers. As we have demonstrated a couple of MapReduce applications on top of raw data, we have NYSE parser.java already. Okay, now we will create another parser for company. For that, we have to right click on the parsers package and then click on new, click on class and name it as company parser and hit enter. And here we need to create all the fields. So let me create all the fields for my company dataset. So these are the fields. Stock ticker is the first one, and then stock name, last sale, market cap, IPO year, sector, and industry. So the interested ones as part of our downstream implementation of this join are name, sector, and industry. Okay. So once you create the all the attributes, we have to create getters and setters for this. For this, select all the attributes, right click on this, go to source and click on generate getters and setters. And I want to generate getters and setters for everything after last member, and click on OK. So now we have getters and setters. Once we have getters and setters, now we have to develop the parse method, which is void parse and string record. This should be a public method. And then our delimiter is pipe. So we have to come up with a regular expression like this. So we are trying to get split the record by using the regular expression / pipe, because pipe is a special character. If you don't use escape characters, it's actually not a regular expression, but we need to escape so that we can actually split data as pipe. And then we have to assign this dot stock ticker equal to vals/0. Similarly, this dot name equal to vals1. uh, some and continue for all the attributes. So to be safer side, I'm just converting all the attributes, all the values that are split into string and assigning into these things, so that there is no implicit conversion from the values into float or something, because our data set have such kind. So if you go back to data and click on NYSE and click on company list no header.csv, you can see that there are some data which is in numeric form, and I just don't want to happen any implicit data type conversion. For that reason, I am explicitly saying new string for the rest of the fields, just to be on safer side. It might not be required, but I have done that just for to be safer side. So this is how you can actually create the parser, and so using this parser, we have to read that file. Once the data is in memory, we have to as part of the map function, we have to take care of the rest of the stuff to pass that file and build a hash map for using this company parser, so that we can read this data set as part of the map function, etc. We will see all those things as we proceed. For now, that is it. So far, as part of the implementation of distributed cache, we have understand the theory portion of it, and then we have understood the data set, and we have defined the problem statement. And for that problem statement, we started implementing the MapReduce application, and as part of that, first we have created a parser for company because already there is a parser for raw data. That being said, I hope you are enjoying the content on my channel. If you like this video, please click on like button. If you have any technical question or want to provide any feedback, use the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will see a lot more content like this over time. Thank you. Bye.